Hello everyone, welcome to the power pack session for the exam of your Vizag MT Steel. So कैसे हो आप लोग? How are you all? बताओ कौन कौन आ गया? कौन कौन आ गया? Mark your attendance. Mark your attendance, guys. Tell me who has come. So guys, as you all know, Vizag exam is just a few days left. For your exam, just a few days left. This exam is on 13th December. So just a few days left. And in these days, you need a good amount of practice so that you can score a good marks and score a job there. Okay. And I hope all of you are doing very well and your study is going on with full speed. Okay. And for that particular matter, we are bringing you the Vizag special series, and you have already completed the control theory. I am sure you have already completed. Now we are going to start the next subject, which is network theory. So network theory revision series will be of two parts. Part 1 I will take today. Part 2 I will take tomorrow. Okay. So these two parts are going to cover approximately 60 to 70 questions only from the network theory subject. And I hope these questions will help you a lot to revise all the concept. So let me introduce myself. My name is Ishaan Mudgal. I have a 3+ year of experience. I'm 5 times GATE qualified MTech gold medalist from NIT Allahabad, and these are my area of expertise. And guys, you can download our Gradeup app so that you can watch our classes there also, right? And guys, this is the course. First I want to tell you, we have a AE foundation course, JE foundation course, which is going to help you in different state AE JE exam. You can see here UPPSC, BPSC, UPPCL and all other exam. These courses are going to help you a lot, right? From these are our star faculty, and you can see the amount of experience they have. So you can utilize their experience and score good marks in your respective examinations. Okay, and these are our students who scored a good marks in our ESC and GATE exam, and I want your name on this slide next year for sure. Okay, and guys, Gradeup has already launched the Gradeup Super. Gradeup Super is your one-stop destination where you have a structured life course as well as a mock test, so that you can revise your course as well as do the test, and you can see your rank wherever you stand, right? And very important information for you guys, if you're going to join the AJE course before 10 December, you will get a high amount of discount, but after 10 December the price is going to be increased. You can see we have a 3-month subscription, 6-month subscription, 12-month subscription. So select the course wisely and on time. So let's start our today's class, guys. आज की class start करते हैं with this first question, and today we are going to cover many questions. Session is going to be very important for your network theory. So this is the first question, and give me the answer in a comment section. Everyone try this question and give the answer in a comment section. Okay? और बच्चों बताओ कौन कौन आ गया. अपनी अटेंडेंस तो मार्क करो, कमेंट करो, कमेंट करके बताओ कौन कौन आ गया. Okay, so what will be the answer here? What I need to find out, the current in a given circuit with dependent voltage source is. इस सर्किट में मुझे करंट बताना है वो कितना फ्लो करेगा, राइट? बहुत ही बेसिक क्वेश्चन है, बहुत ही बेसिक क्वेश्चन है. जस्ट थोड़े से पॉइंट्स आपको इस क्वेश्चन के लिए पता होने चाहिए. ओके, जल्दी मुझे इसका आंसर बताओ क्या होगा. जल्दी से बताओ इसका आंसर क्या होगा बच्चों. एंड ज्वाइन करो, सब लोगों को बुलाओ, अपने फ्रेंड्स को बुलाओ, बिकॉज दिस सेशन इज गोइंग टू बी वेरी इंपॉर्टेंट फॉर योर Vizag एग्जाम. तो लेट्स सी, वी विल अप्लाई द केवीएल. तो सपोज कर लिया कि करंट मेरा इस डायरेक्शन में फ्लो कर रहा है. अब आपको पता ही है केवीएल लगाने के लिए, टू अप्लाई द केवीएल यू हैव टू मार्क द पोलैरिटी करेक्टली. और पोलैरिटी कैसे मार्क करते हैं? टू मार्क द पोलैरिटी, रिमेंबर वन थिंग, इफ यू हैव अ पैसिव एलिमेंट, if you have a passive element and current is enter, then the terminal at which the current will enter will be a positive terminal, and the terminal from which current leaves will be the negative terminal. Okay, so let's see, mark the polarity here. So current I will enter at 1 ohm, so it will be plus minus. Here polarity is already marked, but we have to mark the polarity according to the current. So when this current goes here, the polarity here again will be plus and minus. Then the current will flow through 4 ohm, the polarity will be plus and minus. Okay, now we have to write the KVL equation. सो केवीएल इक्वेशन लिखते हैं एंड जल्दी से इसका आंसर देखते हैं क्या होगा. इफ वी राइट द केवीएल इक्वेशन, सो व्हाट विल बी द केवीएल इक्वेशन हियर? -24 plus I. Now this is a dependent voltage source. If this is a dependent voltage source, the magnitude will give you the voltage. So here I have to write -2 times of VB plus voltage across 3 ohm is already given, it is VB, plus 4I equal to 0. So it become VB minus 5I equal to -24. This is the first equation. पहली इक्वेशन आ गई. Now I need one more equation to find out this variable. So that one equation will come from this particular element. See very carefully. What is the voltage? VB. VB is the voltage across 3 ohm. So I can write 3 multiplied by I. Right? So put the values here. 3 multiplied by I minus 5I equal to -24. And I comes out to be 12 ampere. Simple question. Option B is the right answer. Option B is the right answer. बच्चों try करो बेटा. If you don't try this type of question, then how will you crack the exam? Right? Vizag exam important है. The seats are much there. So you have to score well. You have to practice well. Now next question. Try this question. And remember, today we are going to solve many questions on network theory, and tomorrow also we have a same session of network theory where we are going to solve more questions. Okay, so Abhi has given the answer for the last question. Good, Abhi, your answer was correct. Now about this question. So try this question, bacha. Try this question. Okay, Ashif is asking why, sir, resistor will have the positive terminal. Beta, in passive element, what happened? Resistor is a passive element. So in that case, what happened? The terminal at which the current enters is known as the positive terminal. Why? Because resistor is going to dissipate the energy. Resistor is going to dissipate the energy. So to dissipate the energy, it must be absorbed first. So in this direction, it is absorbing the energy. Okay, that's why here the resistor will be positive terminal. Now solve this question. Let's see how to solve this question. In this, I need to find out the value of resistance R. Okay, simple hai, very simple question. Just you need to understand the concept here. So 4 amperes flowing through a resistor R. Let us suppose a current I is leaving from this terminal, or you can say a voltage source is transferring the current I. So how much current will leave here? If in this branch 4 ampere is leaving, so how much current will leave here? I minus 4. How much? I minus 4. Okay. चलो अब polarity mark करते हैं. Now mark the polarity. It will be plus minus. It will be plus minus. So now I can apply the KVL here. Yes, I can apply the KVL. So if we apply the KVL, guys, what can I write? Minus 50 plus 6 times of I plus 7 times of I minus 4 equal to 0. Yes or no? KVL तो बहुत basic चीज होती है बेटा. KVL is very basic thing. KVL, KCL you should know very properly. So it comes out to be 50 is equal to 6I plus 7I is 13I minus 28. Okay, and from here I can write I is equal to 78 divided by 13. Okay, I comes out to be 6 ampere. So I comes out to be 6 ampere. What I need to find out? I need to find out R. So if I is 6 ampere, so how much current will go there? 6 minus 4, 2 ampere. Now beta, these two are the parallel branch, and for the parallel branch voltage must be same. So what is the voltage across 7 ohm? Voltage is 7 multiplied by 2 equal to what is voltage across 4 R? It will be 4 multiplied by 2. Sorry, 4 multiplied by R. So R comes out to be 3.5 ohm. Option A. See, in this small question, we have seen the two concepts very clearly. First of all, KVL. Second is that if you have a parallel branch, the voltage of those branches will be same. Remember, this is very basic thing. Okay, correct. Abhi has given the right answer. Next question. Again, the question is based on the concept. If you know the concept, you can give the answer easily. The VI characteristic of the element is shown in a figure. in this figure Vi characteristic is given. I need to find out which type of element is this. But I need to find out which type of element is this. Okay, so for this you need to know one thing very carefully. For a linear element, slope must be straight line. For a linear element, slope must be straight line and pass through the origin, and it must passes through origin. Okay, for a linear network. But here you can see the particular is not a straight line, it is changing its slope at this particular point. If changing its slope is at this particular point, it means first of all this graph is non-linear. Okay, now what do you mean by active element? Now graphically, active element means if graph lies in adjacent quadrants. Very important. If graph lies in adjacent quadrant, then it will be active element. बहुत important point है बेटा. What does it mean? If the graph lies in an adjacent quadrant, for example, first and second quadrant, second or third quadrant, third or fourth quadrant, then your particular element is active element. Otherwise, it is passive. So see this diagram very carefully. It is the first quadrant, it is the second quadrant. The graph lies in a adjacent quadrant, so it will be an active element, not a passive. It will be an active element, beta, not passive. Okay. Next, what do you mean by bilateral element? Bilateral element का मतलब क्या होता है? In this mirror image must occur. In this mirror image lies in opposite quadrant. Mirror image lies in opposite quadrant. Very important. For a bilateral network, the graphical representation is that the mirror image must be in opposite quadrant. For example, if I provide you this particular figure, this is the bilateral element. Why? Because you have a mirror image in a first quadrant and in a third quadrant, which is opposite to this. Otherwise, it is non-bilateral, or you can say unilateral. So, which options are given all of these three quantities? Option A. So, Abhi and Vanshika, your answer is not correct, bacha. Correct answer is non-linear, active and non-bilateral. Okay, remember this point. What is the meaning of active? What is the meaning of bilateral? Very important. One question will definitely come in this particular concept. Next. Everyone give the answer for this question. बहुत easy question है. Just you have to interpret the network very carefully. Just have to interpret the network very carefully. Very important question. Very simple question. In this question, I need to find out the current through 120 ohm resistor in the circuit shown below. Okay. Just crack this question. Just crack this question. In this type of question, you need not to spend more than 5 seconds. Okay, if your practice are well enough, you will not spend more than 5 seconds this type of question. Okay, just give the answer. What is the current which is passing through 120 ohm? The question is asking. Okay, just 5 to 6 seconds, nothing more in this question. See beta very carefully. I need to find out the current which is passing through 120 ohm. Okay, so see here. This current 25/7 ampere entering at this terminal, and you will see 4/7 ampere is leaving. Okay, so here 25/7 ampere entering and here 4/7 ampere leaving. So how much current will leave here? 25/7 minus 4/7 comes out to be 21/7 equal to 3 ampere. So answer कितना हो गया? 3 ampere. Correct अभी? Answer कितना हो गया बेटा? 3 ampere. Okay, and this question has been asked in the IES exam plus in a RRB SSC exam. Sorry, RRB JEE exam. Okay, so these type of question are very important, beta. You just need to interpret. There is no use of voltage source here. Okay, correct, Abhi, correct, Vanshika. Next question. Next, everyone, and one of the most important question of today's class. In this question, we need to find out by what angle inductor voltage leads the capacitor voltage. Now phasor difference जो होता है वो नेटवर्क में बहुत ज्यादा इंपॉर्टेंट होता है, and not for the network. A phasor difference, if you know, you can solve the question of machines, you solve the question of power system, you can solve the question of control and power electronics if you know the phasor system correctly. Okay, so tell me, everyone, give the answer for this question. Consider the following circuit. For the circuit shown below, by how much the voltage across the inductor leads the voltage across the capacitor. This question can be solved easily if you know the phasor difference correctly. If you know the phasor diagram, you can solve this question very easily. So first of all, I am converting this capacitance into reactance form. Okay, reactance form. What is the XC? XC will be minus J divided by omega C minus J divided by 2 multiplied by C, which is 0.1. Okay, so it comes out to be minus J. This is the reactance of capacitance, or you can say capacitive reactance. Now see here very carefully. This voltage, which is 2 angle 0, it is across the 1 ohm as well as it is across the 0.5 ohm also, right? It means this particular voltage is across a resistor also and across the capacitor also. So let's suppose I am taking this voltage as a reference. I am taking this voltage as a reference 2 angle 0. Okay. Now what will be the current which is passing through this resistor? Obviously, if you know the voltage, a resistor current will be in phase with the voltage. In case of resistor, remember, in case of resistor, voltage and current are in phase, right? Now the current in the capacitor must lead the capacitor voltage by 90 degree. So this is the capacitor voltage also, this is the capacitor voltage also. So capacitor current must lead the capacitor voltage by 90 degree. Remember this point. Okay? Now what is the inductor current? You will see inductor current is a phasor sum of capacitor current and a resistive current. So here I will get the inductor current somewhere here. This is my inductor current. Now what will be the angle of this? This angle will be 45 degree. Yes or no? This angle will be 45 degree. Why the angles are same? Because the magnitude of IR and IC are same. And why the magnitude is same? Because the reactance is same. Okay, got my point. Now finally I need to find out the inductor voltage. So remember one point, bacha, inductor voltage leads the inductor current by 90 degree. So here you will see inductor voltage will be here, which leads the inductor current by 90 degree. Okay, so I need to find out phasor difference between VL and VC. So between VL and VC, this is the angle which is equal to 90 plus 45, comes out to be 135. So yes, Ramadhisu is given the right answer, and एक और से आंसर दिया Vasavraj is given the right answer also. Good, very good. Okay, just you know the concept of phasor diagram, and just you should know, in case of a capacitor current, it leads the capacitor voltage by 90 degree, and in case of inductor current, lags the voltage by 90 degree. Okay, next question. For the AC circuit, remember one point, beta, AC questions are very favorite for these type of exam. AC circuits or AC questions are very favorite. So you have to be good practice in AC also. Okay. So in this question, for the AC circuit given below, what is the value of I? What is the I? I is entering inside this network. I need to find out the value of I. So you should know how to solve this question in a less amount of time. Good Yashwan. It should be clear. It should be clear because the exam is just a 10 days ahead. Okay, or 9 days ही बचे 13 को exam भी आपका. Okay, so let's see. In this, I need to find out the current. So, people who don't know the concept correctly, what they will do, they will try to find out the total impedance first. Okay, but one thing you should know very carefully. If you have a parallel branches connected, it will be easier to find out the total admittance as compared to total impedance. Okay, what will be the total impedance? It will be the impedance of first branch plus impedance of total admittance. My fault. What will be the total admittance? In parallel, total admittance is equal to admittance of first branch plus admittance of second branch. So first branch का admittance क्या होगा? It will be 60 plus J60. What will be the admittance of second branch? It will be minus J120. It will be minus J120. Okay. Now, if you solve this particular question, you will get 0.833 into 10 raised to power minus 2 angle 0. When you solve this particular thing, you will get this type of answer. Okay. Now, what will be the current I? Current I will be 120 angle 0 multiply by total admittance. Okay. So 120 angle 0 multiply by 0.833 into 10 raised to power minus 2 angle 0, and approximately we are going to get 1 angle 0. Now 1 angle 0 is what? 1 angle 0 is 1 plus J0, which is option B. Okay, but AC's questions are very important for your exam. Remember this point. Now next, one of the most important exam for your exam, for your question for your exam. Very important. In the circuit shown in the figure, the current through the inductor L is. I need to find out the current which is passing through inductor. Okay, this current I need to find out IL. Now try this question. Everyone should try this question, then give me the answer. Everyone should try the question, then give me the answer. And guys, don't forget to like the session, and session को इतना spread कर दो, अपने दोस्तों को बताओ, so that they can also utilize from this type of sessions. And you know, daily we are providing you sessions for the Vizag exam. So I hope you are all attending those lectures. Okay, because in just 10 days you need a revision. You need a revision. You need not to touch any new topic. You need to revise the topic that you have already covered. So Abhi has given the option A. Okay, Ramadesu has given the option A. Let's see. Okay. Anyone else? Right now 13 people are online and only 2 people has given the answer. Sab log answer ho. Everyone should give the answer. A, B, C, D. In the circuit shown below, what will be the current through the inductor L? Okay, 0 ampere. Mayur has given the 0 ampere. Now beta, here you will see this is the concept that you should know very carefully. First of all, this is a AC circuit. Now how can I know this is a AC circuit? Because I have an inductor and capacitor. Okay? In AC circuit, you need to remember one point very carefully. KCL and KVL are written in a form of a phasor form, not in a magnitude form. For example, if this is inductor current, this is a resistor current, this is a capacitor current, and this is the total current, then total current phasor is equal to resistive current phasor plus IL phasor plus IC phasor. So this is the form of KCL. This is the form of KCL. Okay. Now if I want to write in a magnitude form, then in magnitude form, or you can say first of all I want to write in complex form. In complex form, it will represent like this. It will represent like this. This is the complex form. This is the complex form. Now if I want to write down in a magnitude form, then total current magnitude will be under root of IR square plus IL minus IC whole square. This is the magnitude form. Remember this point. In this way we need to apply the KCL. Now all of you did one thing. You just subtract 5 minus 5, which is wrong. You cannot write that IL is equal to 5 minus 5 equal to 0. This is wrong. Why? Because here you are doing the magnitude subtraction, but in terms of magnitude, this is the KCL you should write, because this is a phasor quantities. In the AC, you are dealing with the phasor quantity. Okay. So first of all, you know what is the magnitude of IC current. You know what is the magnitude of IC. Magnitude of IC is 4 ampere. Directly it is flowing. So I need to find out the magnitude of IR first. So beta, see very carefully. What will be the magnitude of IR? It will be under root of total current 5 ampere which is flowing whole square minus the capacitor current which is flown out. So IR comes out to be how much? It comes out to be 3 ampere. Okay. Magnitude of total current is nothing but equal to 5 ampere. Now put all these value in this equation. So it become 5 square is equal to 3 square plus IL I need to find out. IC is equal to how much? It is 4 ampere whole square. So after solving this, you will get IL minus 4 whole square equal to 16. IL minus 4 is equal to 4 and IL comes out to be 8 ampere. 8 ampere. Beta, we are dealing with the phasor quantities in case of AC. If this question deals with the DC, then you can directly write the 0. But because in DC we deal with the magnitude, in AC we deal with the phasor. So remember this point very carefully. What happened in case of a AC? You have to write the KCL in phasor quantity. This is in complex quantity and the last is the magnitude quantity. So the answer is 8 ampere. Next question. Next, everyone solve this question. And if you have any doubt in the last question, you can ask. Okay. कोई भी doubt हो बच्चा, if you have any doubt at any time, you can ask in a comment section. Good Mayur. Good Mayur. These sessions are totally made up of so that you can understand the small mistake that you do in your exams. So next question. Three currents I1, I2 and I3 are approaching a node. So I have a node in which three currents are approaching like this. I1, I2 and I3. Okay, I1, I2, I3. Now you need to find out the I3. So I know using KCL. I know bacha using KCL what will happen? Using KCL I1 plus I2 plus I3 equal to 0. Okay, Ramadesh is asking, sir, please explain once. Okay, beta, after this question I will explain. After this question I will explain. Okay. So using KCL, you know I1 plus I2 plus I3 is equal to 0. I need to find out I3. What will be the I3? I3 is equal to minus of I1 plus I2. Okay. Now what is I1? If you see, I1 is given 10 sine 400t plus 60. I can note down like this, 10 angle 60. Okay. Next, I2 is given 10 sine 400t minus 60. Okay. So I can write 10 angle minus 60. 10 angle minus 60. Now what will be the I3? I3 will be minus of 10 angle 60. 10 angle 60 plus 10 angle of minus 60. Okay. Now when you solve this equation, it comes out to be minus 10 angle 0. It comes out to be minus 10 angle 0. Now what is the base? Base is sine 400t. So minus 10 sine 400t plus 0, which is nothing but minus 10 sine 400t ampere. So कौन सा option सही है? Option C is the right answer. Correct. Correct. Ritesh, no beta, your answer is wrong. Just check your calculation. Your concept is correct. Rohan has given the right answer. Okay. So let me explain once more the KCL. Let me explain the KCL. Just let me add a page. जल्दी से एक page add कर लूं. Then I will explain you the concept of KCL in case of AC. So see. KCL in case of AC. KCL in case of AC. For example, I have three branches. This inductor and this I have a capacitor. Okay. Remember one point. In AC, we deal with the phasor quantities. In AC, we deal with the phasor quantities. We don't deal with the magnitude directly. So whenever I need to write down KCL, I need to write down in a phasor form that IR phasor is total current के बारे में लिखना है. Sorry. So I have to write down total current phasor is equal to IR phasor plus IL phasor plus IC phasor. This I am talking about. This is R, this is L, and this is C. Very important beta, very important. C, L and R. This is a total current. Okay. and you have a current in each branch. So always remember, in case of AC, you need to write down in phasor quantity. Okay. Now for a phasor quantity, I require both magnitude and angle, which is theta, right? But if theta is not given, then how can I solve this? If theta is not given, so you should understand one point very carefully. IL and IC are always the imaginary term. IL and IC are always the imaginary term. So I can also write down that total current is equal to IR magnitude plus J times of IL magnitude minus J times of IC magnitude. Okay. Now from here I can take the J common. If I can take the J common, so in magnitude form. Now in whole equation you are only seeing the magnitude. In whole equation you are only seeing the magnitude. Right? Yes or no? In whole equation you are only seeing the magnitude. So if it is only the magnitude, guys, so now how can you write down the magnitude from this particular equation? IT magnitude is equal to, पता है ना आपको, Z is equal to x plus jy होगा, तो Z का magnitude क्या होगा? Root of x square plus y square. The same thing is happening here. It will be IR magnitude whole square plus IL minus IC magnitude whole square. Okay, got my point? Okay, this always remember, KVL and KCL and current or voltage are always in a phasor quantity in case of AC. Okay, next question. Now, very good question. Very good question. Now try to solve this question, everyone. In this question, I need to find out which options, which particular statements are correct. Okay, in this I need to find out which statements are correct. Everyone, tell me which should be the answer here. What should be the answer here? Consider a circuit with respect to this circuit. क्या दिया हुआ है? Circuit is, this is 100 ohm. We have inductor voltage of 150 volt. Inductor voltage कितना दिया है? 150 volt. Ritesh, what you are saying, beta? You are saying J square is -1. Yes, beta. J square is -1. What's the problem in that? Okay, now see this question very carefully, guys. I need answer for this question. I need answer for this question, everyone. Okay, let's see how to solve this question. Now what is given? We have given that this is the source voltage 250 root 2. 250 root 2 sine 300t. This is a resistive voltage. This is the inductive voltage. So I need to find out which statements are correct from these three statements. Okay. So we will solve this question very carefully. First of all, what is the magnitude of source voltage? And I need to find out the RMS. So this is the maximum magnitude. What is the formula of RMS voltage? It is 250 by root 2 divided by root 2 equal to 250 volt. Now you can ask me, sir, why you are finding out the RMS voltage? Beta, why I am finding the RMS voltage? Because inductor RMS voltage is given. Because inductor RMS voltage is given how much? 150 volt. Okay. Now again I told you, you cannot apply the KVL directly in terms of magnitude. In terms of magnitude, you have to write down the voltage across the RMS is equal to under root of source RMS whole square minus inductor voltage whole square. Yes or no? Yes or no? ऐसा क्यों हुआ? ऐसा क्यों हुआ? Because again, if I apply the KVL in phasor form, VS phasor is equal to VR phasor plus VL phasor. If I only talk about magnitude, then VS square is equal to VR square plus VL square, magnitude wise. So from here you can see what is the magnitude of voltage across R. It will be root of VS square plus VL square. So what is the source voltage magnitude? It is 250 whole square minus VL square. VL is 150 whole square. Okay. When you subtract these two quantities and take the under root, I guess you will get 200 volt. You will get 200 volt. it means this option is not correct, which means this option is not correct. Okay, so first option is not correct. Now beta see very carefully. A, C, D, in all of these three options, one is given. It means the correct answer is option B. Okay, so in exam, you no need to check other two statements if this type of condition occur. But here I will check these two other statements also. So the first statement is wrong. The resistor voltage is 200 volt. Now they are asking the current in RMS form. So I know the voltage across resistor. I know the value of resistance. Then what will be the magnitude of current? The magnitude of current will be resistor voltage RMS divided by R. Okay. So VR RMS kitna aa gaya? 200 divided by R, which is 100, comes out to be 2 ampere. So this option is absolutely correct. Now I need to find out the inductance also. So for inductance, you know the magnitude of reactance will be inductance voltage divided by the current. What is inductance voltage? 150. And you know this current, both are connected in series. So this current is also passed through inductance. So it comes out to be how much? 2. So reactance comes out to be how much? It comes out to be 75 ohm. Now what is the formula of reactance? Formula of reactance is omega L is equal to 75. Now L comes out to be 75 divided by 300. Why 300? Because the frequency is given, omega is 300. So when you solve this thing, you will get how much? 0.25. So this value is also correct. But in exam, if you get one correct answer, okay, like this, no need to check other options. Okay, no need to check. Otherwise, you are just wasting your time. Next question. What is the current through the 2 ohm resistor? I need to find out the current which is passing through the 2 ohm resistor. Everyone, jaldi se question solve karo. We have many questions left. We have to cover every question. जितने ज़्यादा क्वेश्चन आप करोगे ना, उतना ही आपको सीखने को मिलेगा. More questions you do, more you can understand the concept, more you can do the practice. Okay, so everyone, what is the current through the 2 ohm resistor for the circuit as shown below? In this, I need to find out the current through 2 ohm resistor. Now, see this circuit very carefully. This is the voltage dependent voltage source. So this is 6V, where V is variable. And what is V? V is the voltage across 2 ohm. But you need to see one thing very carefully. This V is just a volt. Why? Because here you can see this is an independent source. This is the sign of independent source, and diamond shape is a sign of dependent source. Okay, keep this point in your mind. So I can apply the KVL here. Why? I know the voltage is 6V here. So if I apply the KVL, I can write minus 6 times of V plus voltage across 2 ohm is V plus the voltage source magnitude is 20 equal to 0, right? So 20 equal to 5 times of V. From here, V comes out to be 4 volt. V comes out to be 4 volt. Now if V is 4 volt, I know the resistance. Can I find out the current? Obviously. What will be the current here? Current is 4 by 2 comes out to be 2 ampere. Option D. Okay. This question is important. Why? Because some students can get confused in this and this. But remember one point very carefully. If this is your independent source. In your independent source, your voltage is always fixed. This is your dependent source. It means it depends on the voltage across 2 ohm. Okay. Fine. Next question, very important question, very important question. Again, see, in every question I am giving you new concept to revise. Okay, it may happen you have learned this concept earlier or not. Okay, हो सकता है concept आपने पहले पढ़े हो सकता है आपने ना पढ़े हो. Okay, if you have already understood the concept, then you can just revise it. If you don't understood this concept earlier, then you are understanding right now. Okay, so this question, very important question. The voltage and current waveform of the element are shown in below. The circuit element and its value are. So this is what? This is the current. This is the voltage equation. So first of all, if I talk about the resistor. In resistor, voltage is equal to R times of IT. See, so the in resistor what will happen, the waveform of voltage and the waveform of current will be same because R is a constant, so the waveform will be same. So here the waveform are different, so obviously resistor is not the answer. If I talk about the capacitor, what happened in case of capacitor? What happened? What is the equation in case of capacitor? Capacitor current IC is equal to C times of dV by dt. It means when you differentiate the voltage multiply by the current, it will give you the capacitor current. Okay. Now here you can see you have a Vt is a step signal. Vt is a step signal till 2 seconds, and this is the ramp signal. This is the ramp signal. Now from the signal and system, one point you should know very very carefully. Differentiation of ramp give you the step, and differentiation of step give you the impulse. So see here very carefully, the voltage is in step. If you differentiate it, you have to get impulse current in case of capacitor, but here you are getting a ramp, so it means capacitor is not the answer. Now if you talk about the inductor, in case of inductor, what is the equation? Inductor voltage is L times of di by dt. It means, now see very carefully, this is the ramp. If you differentiate the ramp, you will get the inductor. Sorry, if you differentiate the ramp, you will get the step. So you are differentiating the current, you are getting a voltage. It means this is the element of inductance, because in inductance when you differentiate the current, you will get the voltage. Got my point? Yes or no? Now I need to find out the magnitude of inductance also. Okay, so see here very carefully. From 0 to 2 seconds, if I talk about 0 to 2 seconds, what will be the change in time? Change in time is 2 seconds. What is the change in current? Change in current is final current minus initial current. 2 minus 0 equal to 2 ampere. And what is the voltage during this time? It is 2 volt. Now put all the values here. 2 is equal to L multiply by change in current, which is 2, divide by change in time, which is 2. So inductance come out to be how much? 2 Henry. Inductance comes out to be 2 Henry. Option C. So beta, in this there are two concepts which are including. One is the signaling system, second from the networks. So from the signaling system, you should know this point very very carefully, that the differentiation of ramp give you step, differentiation of step give you impulse. You can also say integration of impulse give you step, integration of step give you ramp, and integration of ramp give you parabola. Okay, and you know this equation from the network, then you can relate these two things and you can say this is the inductor. Any doubt here? Anyone? Any doubt? So if you don't have any doubt, then next question. This question is from the three-phase circuit. One of the important topic for your exam. One of the important topic for your exam, three-phase circuit. And guys, don't forget to like the session. One of the important topic for your exam, three-phase circuit. A balanced delta connected load, they have already given, you have a delta connected load, impedance given is 16 plus J12. Okay, a balanced delta connected load is connected to a three-phase 230 volt balanced supply. Okay, always remember, whenever the supply is given, that supply is given in a line voltage RMS form. Always remember this point. If nothing is mentioned, then given voltage of the supply is always the line voltage in RMS form. Is baat ko yaad rakhna. Now I need to find out the line current and the real power drawn. To solve this question, you need to understand two things. First of all, what happened in delta connection, that you should know. In delta connection, line voltage magnitude is equal to phase voltage magnitude. Okay, and line current is magnitude is root 3 times of phase current magnitude. In case of star connection, what will happen? In case of star connection, line voltage magnitude is equal to root 3 times of phase voltage magnitude, and line current is equal to phase current magnitude wise. Okay. And if I talk about the impedance per phase, it will be sorry, phase voltage divided by current per phase magnitude wise. Again, I'm talking about everything is magnitude wise. Okay. Now using these all concept, I need to solve this question. So first of all, I need to find out the line current. So this is the line voltage RMS. They have given the magnitude and the connection is delta. If the connection is delta, what will be the phase voltage? It is going to be equal to line voltage. It's equal to 230 volt. Okay. What is the magnitude of impedance? Magnitude of impedance is 16 square plus 12 square. So just do the calculation very quickly. It comes out to be 20. If I am not wrong, 256, 144. Yeah, it comes out to be 20 ohm, right? So what will be the phase current? What will be the phase current? The phase current is going to be voltage phase divided by impedance, right? What is the phase voltage? It is 230 divided by impedance, which is 20. So it comes out to be 11.5 ampere. It comes out to be 11.5 ampere. Now beta, listen very carefully. This is the current phasor. I need to find out the line current. So the line current is root 3 times of I phasor in case of delta. Right? So it comes out to be root 3 multiplied by 11.5. It means 19.9 ampere. So this is the line current. 19.9 ampere. Okay. Now the real power. The formula of real power in 3-phase circuit. It can be a delta connected. It can be a star connected. But the formula is root 3 VLIL cos phi. Root 3 VLIL cos phi. This is the formula going to use both in delta and star. So I know the line voltage. The line voltage is 230 volt. I know the line current. It is 19.9 ampere. I need to find out the power factor cos phi. Okay. Now what is the power factor? Phi is equal to tan inverse of 12 by 16. Tan inverse of 12 by 16. Now you can ask, sir, what is 12? What is 16? Beta, it is the impedance. What is the load angle? Load angle is equal to tan inverse of imaginary part divided by real part. Okay. So 12 is the imaginary part divided by 16. So I can use the calculator. So let's use the calculator. So it comes out to be angle is 36.86. Angle is 36.86. Now put all the values here. So power is equal to root 3 times of line voltage. What is line voltage? It is 230. What is line current? Line current is 19.9 multiply by cos 36.86. Okay. So here when I solve this equation, cos multiply by 19.9 multiply by 230 multiply by root 3. So it comes out to be 6.34 kilowatt. 6.34 kilowatt. Now 6.34 kilowatt. What is the answer? 19.9 and 6.34. Option C. Okay, option C. Okay, but remember this thing very, very carefully. This is very important. And this concept is going to use in power system also, in machine also. Okay. So one question you can expect from this particular concept in any of these 3 subjects. Fine. Now next question. It is very, very easy. It is very, very easy to solve this question. This question is very, very easy. Just 5 seconds से ज़्यादा नहीं होने चाहिए इस question में. Question क्या है? A balanced load of 5 plus J4 is given in delta. What is the impedance per phase of the equivalent star connection? So if all the impedance are equal, then impedance of delta is equal to 3 times of impedance in star. Remember this point. If all the impedance are equal, then impedance of delta is equal to 3 times of impedance of star. Now delta impedance is given how much? It is given 5 plus J4. I need to find out star impedance. It will be delta divided by 3. It will be 5 plus J4 divided by 3. It comes out to be how much? 5 divided by 3. So 2 point something. Sorry, not 2 point. 1.6 something. Plus J 1.33. Right. Option B. Option B. Correct? This concept you need to remember. Correct. Everyone is correct. Dave, PSB, Rohan is correct. Absolutely correct. Now next question. Next question. Which of the following can produce the maximum induced voltage? And everyone remember, tomorrow also the same time 10 PM we are going to do the part 2 of network. And kal ki class mein the topics that we are going to cover is the transient resonance and network theorems. Okay, or two-port network. Okay, so some questions I will bring for all of these chapters. So which of the following can produce the maximum induced voltage? Sorry, not induced. It's not induced. Maximum inductor voltage. It is inductor. It is inductor. Maximum inductor voltage. Question is maximum inductor voltage. Okay, which of the following can produce the maximum inductor voltage? Now, inductor voltage is equal to what? If I talk about magnitude only, it will be XL multiplied by current. XL multiplied by current. What is XL? XL is nothing but it is equal to omega multiplied by L multiplied by current. Now you can see inductor voltage is directly proportional to frequency. So if I increase the frequency, inductor voltage will also increase. Okay. So see very carefully. In DC current, inductor will behave like a short circuit. So the voltage is 0. In DC current, inductor behave like a short circuit. So the voltage will be 0. But in AC current, inductor can write in this form. So if you increase the frequency, the inductor voltage will increase. So it is 490 Hertz, it is 60 Hertz. So obviously option D is the right answer because the frequency is higher as compared to C. Next question. Very easy question. Is question number 4 though. Just give this answer very quickly. This is the question has been asked in a RRB A paper, and also this question has been asked in UPPCL, and also this question has been asked in IES exam. Okay. So everyone, very easy question. I need to find out what will be a resistance seen from the terminal AB. I need to find out a resistance seen from the terminal AB. So see very carefully. This is the IV characteristic. What is the resistance? Resistance is 1 divided by slope of IV characteristic. Okay. Or you can write down change in voltage divided by change in current. Change in voltage divided by change in current. So this is 20. So here, if I talk about this point, this is 20, 0. If I talk about this point, this is 0, -4. So change in voltage, in a final voltage, 20 voltage minus initial voltage. So 20 minus 0 divided by change in current. Final current is 0, initial current is -4. So it comes out to be 5 ohm. Now beta, Rohan and Ramadesu, do the calculation very carefully because most of the students will give the -5 ohm. But think about this. This is a straight line which slope is increasing and the slope is positive here. Negative resistance can also come. That's not the problem. Okay, -5 ohm can become. But for this question, you can see the slope is increasing. The graph is increasing. Okay, good. Next question, everyone. This question is from the maximum power transfer theorem. Very easy question. Very easy question. Read this question carefully and give me the answer. Read this question carefully and give me the answer. Everyone. If the combined generator and the line impedance is 5 plus J10 ohm, it means one impedance is given 5 plus J10 ohm. Then for the maximum power transfer to an impedance from a generator of a constant generated voltage, what will be the load impedance? Okay, they have given so many information, but one thing you should understand, for maximum power transfer, load impedance must be equal to conjugate of all internal impedance, or you can say Thevenin's impedance. Okay, So this is nothing but the Thevenin impedance. Why? Because they have given it is the combined impedance of generator and the line impedance. So just what should I do? 5 plus J10 conjugate. What is the meaning of conjugate? You need to change the sign of complex quantity. It becomes 5 minus J10. Option B. Option B. Correct. So guys, this question you should also see. Okay, एक दो question और देख लेते हैं, and I will give you some question and homework. I will give you some question homework. You need to answer it in a comment section. And if you're watching the recorded session, guys, then you should also give the answer in the comment section after the video. Okay, Shekhar. Okay, Shekhar. I will ask them. But can you tell me which videos are deleted? Can you better tell me? Or you can also tell me this in a comment section after the videos, and you can tell us which videos has been deleted. So superposition theorem is not applicable for, first of all, every theorem is applicable for bilateral. Every theorem is applicable for bilateral passive linear time invariant network. Okay, every theorem is applicable for this. So superposition theorem applicable for voltage calculation. It is applicable for bilateral also. It is applicable for passive also. But it is not applicable for power calculation. Remember this thing. It will not applicable for power calculation. Means you cannot say total power is equal to P1 plus P2 so on. What is the P1 plus P2? Power from individual source. Power from individual source. Power from individual source. So this is the wrong statement. This is the wrong statement. Only in voltage and only in current I can write V1 plus V2 till Vn, and for total current I can write I1 plus I2 till In. This is the right statement. This is the wrong. Fine. Now take this question in homework. Everyone take the screenshot. सब लोग इसका screenshot लो. Everyone take the screenshot and give the answer in a comment section after video has ended. Okay. This you should do the homework. This question you should do in homework. Okay. These two questions are your, and take this question also. So do these three questions in your homework. Take the screenshot. Take the screenshot. I need answer in the comment section. Okay. And beta tomorrow we are going to see the transient two-port network and some question of network theorem also. Okay. So be on time tomorrow. आज आप लोग late हो गए थे. कल time पर आना है 10 PM correct time. Okay. Fine. Everyone, these three questions are the homework. Right. I hope guys you enjoyed the lecture. Yes or no? Tell me. Everyone, do you enjoy the lecture? And guys, just 9 days are left for your exam preparation. इतनी जोरों से कर दो कि आज तक आपने preparation ना की हो. You need to crack this exam. Okay. So bye guys. Take care. Good night. Sleep well.